Alright, so coming back to problem number 3, the two things that we're interested in finding are our kinetic friction and the coefficient of kinetic friction. So, being that we're interested in finding our kinetic friction, we have kinetic friction over here. So if I was to try to solve this out, we have our kinetic friction, and do we have this value, our FGX? No, but we do have it over here. So if I have two unknowns, I'm not going to be able to find out what my kinetic friction is equal to. So let's find out what our FGX is equal to. To do that, what I'm going to do is I'm just going to scroll down a little bit, just like we did in the last problem. And I'm going to redraw my triangle over here. And we have our 32 degrees in here, our FG, FGY, and FGX. Okay, so what are the different parts of this triangle? What does the FG represent? Hopefully you're saying to yourself that that's our hypotenuse. And what about the FGX? Well, that's our opposite side. And what about the FGY? That is our adjacent. All right, so, hey, wait a minute. I don't have any one of these values for any of the sides over here. So how am I supposed to do this problem? Well, we could figure out what the Fg is equal to, our force due to gravity, being that we do have the mass over here. So let's just do that simple calculation. Okay, so we have this value now. And once again, which value are we interested in? FGY or FGX? Considering the idea that, once again, we're trying to find out what our kinetic friction is equal to, which is over here. So therefore, we're interested in finding out the value for FGX. So FGX is our opposite. We are given our hypotenuse, so which trig function are we going to be using? Okay, so once again, we're looking for our opposite, our FGX, and we're given our hypotenuse, FG, which is 147. So opposite and hypotenuse, which one do we want to use? Hopefully you're saying to yourself, the sine function. Multiply by 147 on both sides of the equation, and we'll get our answer. Once again, make sure that your calculator is in degree mode, not radian mode. If it's in radian mode, you will get the wrong answer. Okay, so we have 77.9 newtons is our FGX. So I'm just going to do that simple substitution. Our mass is 15 kilograms, and our acceleration is 0.3 meters per second squared. All right, and all we have to do is isolate our FK, and then we'll get our answer. So what's 15 times 0.3? And so now we just have to continue to isolate the FK. We have a positive 77.9. So how do we get rid of a positive 77.9? And if negative FK is equal to negative 73.4, what is positive FK equal to? And that is one of our final answers, which we could see confirmed right up here. But that's not it. We're also looking for our mu k. And the thing is that we know that Fk is equal to mu k times Fn. All right. So once we get this, we'll be done with the problem. So we have our fk, which is 73.4, is equal to our mu k times fn. Oh, wait a minute. Do we have our fn value? No. Oh. But we do have fn over here. So, fn minus, do we have our fgy? No. But we do have fgy over here. So, once again, if we actually just do another trig function, we'll be able to get our answer for fgy and plug that into here, and we're done. So, fgy is adjacent, and our given information is our 147, which is our hypotenuse. So adjacent and hypotenuse, which trig function are we going to be using? Hopefully you're saying to yourself, the cosine. Multiply 147 both sides of the equation, and you'll get your answer for fgy. Okay, so we have 124.7 is equal to 0. Okay. And okay, so all we have to do is add 124.7 on both sides of the equation, and we will get our fn. And that's what we plugged down into here. Last thing that we have to do is solve for our mu k, divide 124 on both sides of the equation, and we'll get that answer. And I have 0.59 is equal to mu k. And that's the answer for that one. Let's see here that we got that correct, and that looks good. Okay, this is complex. This is one of those situations where we're dealing with a problem that's very complex, the most complex that we'll actually be dealing in this entire course. If need be, watch this video again, and possibly even for a third time. That's my suggestion to you.